Hello and welcome to R&D Mathematics. Today we are going to talk about higher degree polynomials. Higher degree polynomials. Now, polynomial is an expression that can have constants, variables, and exponents that can be combined using addition, subtraction, multiplication, and division. But you are not allowed to divide by a variable. So let me write down not allowed to divide by a variable. So for example, f of x equal 1 over x minus 2. This is not a polynomial. This is 1 over x minus 2. This is not a polynomial. Nope. And so simply polynomials are things like this. Let me give you some example, then you will understand. Everything is in the numerator. So for example, let's say f of x equal x cubed plus 3x squared plus 2x plus 4. This is a polynomial. And these numbers, we call them coefficient. Here the number is 1, coefficients. And also this number, you can take it as coefficient, but we have a special name for that. That's the constant term. Coefficients. Now, for example, coefficient can be any number. It can be 1/2. You only cannot divide by variables. So for example, g of x equal 1 minus 1/2 x squared plus 3x plus x to the 7th. Is this the polynomial? Yes, of course. But there is a difference between these two. For this one, we call it that's in the standard form. That means, if you think carefully, the powers of x are in order. The highest power first, the next highest, and so on. Here it's not. So this is not in standard form, but still it's a polynomial. Now the next thing we are going to learn, next term involving polynomial is the degree. Degree of a polynomial is the highest power of variable. So highest exponent of the variable, in simple words. Now let's see some examples in order to understand this. Let's make a table. So the polynomial, and then we have the degree, and there is another one which is known as leading coefficient. So the leading coefficient means out of all those coefficients, when we make it into the standard form, the coefficient in front of the highest power. For example, the leading variable in this one is 1, and for example in this case again 1, because here it's 1. Constant term. Let's see some examples. So for example, first one, let's say f of x equal x squared plus 3x plus 1. Now this is in standard form. So the degree is 2, the highest power is 2, the leading coefficient is 1, the constant term is 1. And what if I say g of x equal 3x cubed minus 2? Again, it's in standard form as well, and the highest power is 3, leading coefficient again 3 because of this 3, and the constant term negative 2. And what if you had h of x equal 4 plus 2x squared plus 3x plus 4x to the 5th plus 5x cubed? Now this is not in standard form, but yes, if you want, you can rearrange it into standard form, writing down the order. So the first term would be this guy, and x to the fourth power, you don't see any. Then you write this guy, and then this guy, and this guy. So the leading coefficient, first of all, degree is 5 because the highest power is 5. Leading coefficient is the number appears in front of that one is 4. And then constant term is 4, right? So that's the introduction to higher degree polynomials. And for example, we learned deeply about certain kind of polynomials. When the degree is 2, we call it a quadratic function, right? Degree 2 means quadratic function, and we completely talk about that. After that quadratic function, next one is cubic function. Cubic function onwards, we don't have any, like for quadratic function, related one is quadratic equation. Like that, we do not have any particular way of solving, but looking at the example, we can come up with many techniques. Now, our ultimate goal is to be able to draw graphs of polynomial. In order to do that, we'll have to break down this into pieces. So the next one we are going to learn is power function. By power function, we mean f of x equal a to the xn. That's it. And a can be any real number other than 0, because if a is 0, nothing is there, it will vanish. And n has to be greater than 0, and n can be 1, 2, 3, any number. For example, f of x equal x squared. This is a power function. F of x equal 3x to the 7. This is a power function. F of x equal 4x to the 4th. This is a power function. Now, we are going to learn graphs of power function. See, what we are doing here is, well, you will understand when we talk everything, and after we complete all these little titles, and when we go to graphing, you will understand. But for the time being, let's focus on these power functions. There is only one term, right? For example, let's say you had a polynomial like f of x equal 3x to the 7th plus 8x squared plus blah blah blah, all those terms. The power function helps us see this part, the highest power term. There is some relationship between this polynomial and its highest power term. Now let's see. Before that, let's draw a table. A table that should be really helpful. You know what? Let me go to the next page. So I need a bigger n even odd and then we have a. See, because our power function is of the type fx equal a to the xn. So there are so many four different categories that can happen. N can be even and a can be positive. So remember, n, I told you n has to be greater than 0 and n must be 1, 2, 3, 4 and positive integer. So we can divide n into even or odd. And a, there was not much restriction other than a cannot be 0, so it can be pretty much any number, even decimal numbers, even fractions, anything. So we only can divide a into positive and negative. So this combination can be even positive, even negative, odd positive, and odd negative, right? Now, graph. Now we are going to talk about the graph. Graph of even positive 1. Now, can you think of the graph of an even positive 1? Let's see an example and understand it. For example, let's say x squared. That's a perfect. See, n is even, a is 1, so even positive, it belongs to this category, right? So you already know it looks like this. So x squared, this is x squared. And if you think about x to the fourth, we never learned that, but if you think about x to the fourth, what this will do is actually, if you plug these some numbers, it will have the same shape, but it will increase more rapidly, right? This is kind of x to the fourth. And if you add x to the sixth, even more, it will increase faster. The reason is when you have an even power, see for example, negative 2 raised to even, that is positive, right? That is a positive number, not like odd numbers. So even any even power function, it will have this kind of shape. So basically, well, this a in front of it, for example, if you add 7, it will again make it a little bit faster increasing. So since we are here, we are dealing with positive numbers, you always will have this shape for power functions when it is even positive. And when it is even negative, what will happen is, well, with a negative sign, can you remember the transformations that we did? It will switch, or it will flip upside down. It will reflect around x-axis. Now, next one, odd. When n equals odd. When we have odd power, what will happen is we will have negatives and positives. For the best example to think about is x cubed. It will look like this. So this is x cubed. Now, if you think about x to the fifth, it will also have the same shape, but it will increase a little bit more faster than x cubed because it's fifth power. Now, whenever you have an odd power, you will have, see for example, negative 2 to the 7. This is a negative number, so that's why you have both sides of y-axis up and down. So any odd positive, it will have this kind of shape. And odd negative, what will this do is this will flip around. So this will simply flip around, and you will get a shape like this. Now remembering these shapes, basically roughly remembering this shape is helpful. The reason is, for example, let's say you had f of x equal 3x to the 7th plus x6 plus 5x squared plus 7x minus 8. This is a polynomial of degree 7, right? Now our ultimate goal is to draw graphs of complicated things like this. Now one reason, well, we are going to break this into many pieces, finding zeros and intercepts and blah blah blah, all those stories. And the final step would be, after we deal with all zeros and all those things, what will happen to your f of x when x goes to infinity and x goes to negative infinity. Now if you think carefully, when x is a larger number, for example, let's say x is 10,000. When x is 10,000, this term is 3 to the 10,000 raised to 7th power. That is huge number. And compared to this number, the rest of the numbers are negligible. So the behavior of your f of x is approximated. It's getting closer and closer and closer to this power function. And so because of that, see 3x to the 7th. So that belongs to odd positive right here. So your power function, after we, this in the middle, so many weird things may happen, but when x is getting larger, it will go to negative infinity from this side and positive infinity from this side. That is the reason why we are learning power functions here. I'll explain that again when the time is right. Okay, for the time being, that's enough stories about that. And let me end this video with a quick note because it will fit nicely here. So the domain and range, let's write down domain and range. So domain and range. Domain, when it's even positive, obviously negative infinity to infinity, but the range is 0 to infinity. Odd positive, again the domain is negative infinity to infinity, but the range is negative infinity to 0. And these four cases, everything, 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 and everything. Okay guys, I think that's enough for today's video, and in the next video we'll be talking about zeros of polynomial functions.